This is the second video for my sub plans for 11, 12, 15, and you're working on hyperbolas. And at this point, you should have already corrected the homework. You should have looked at the warm-up assignment. There was a packet, and you were supposed to check your own answers, and so you should be clear on how they took the equation, which was in general form, and put it in standard form, and then found the features of the ellipse. And now we're moving on from ellipse. You should have used the two GeoGebra applets, and you should have answered some questions that I posted at the end of the last video, and now we're ready to move on. So now we're going to go over some things, and I want you to take a minute and open up the hyperbola packet that is under the resource section of today's plan. And I want you to copy the notes that are right here in this packet, as well as these notes. And what I'd like you to do is copy this onto clean notebook paper labeled hyperbola. When you're done copying both of these from the packets, then the video can be turned back on and we will proceed. So the video should be shut off now. And on clean notebook paper, you're going to copy this stuff, and you're going to copy this stuff. Turn the video off now. Okay, hopefully you figured out a lot of that stuff just by looking at the GeoGebra applets. You guys are really smart, so I'm guessing that you did. And now let's look at a general form equation of a hyperbola. And of course, in order to take that general form equation and put it in standard form, we get to do our favorite, complete the square. Woo! So the first thing we're doing here is we're grouping terms. You will notice that I grouped the 9x squared and the 90x, I circled those, and then the negative 4y squared and the 32y I boxed off. And then you can see that that becomes 9x squared plus 90x minus 4y squared plus 32y equals 197. The only real math I did here was I rearranged this stuff so that the x terms were together and the y terms are together, and I subtracted 197 from here and 197 from here so that the 197 is over on the right hand side of the equation. You do not need to copy this down with your other notes because it's in the packet, and so if you ever feel like you need to go back and have it written down in your own notes, you can do that. But right now I just want you to listen and make sure that you're completely okay with this and the process of completing the square on the general form to put it in standard form. Okay, so now what we're going to do is we're going to factor out from the 9x squared and the 90x a 9. Well, 9x squared divided by 9 and 90x divided by 9 gives you 9 times the quantity x squared plus 10x. And then up here we can take a negative 4 out here from both of these terms, and so that's going to give me negative 4 times the quantity y squared minus 8y. And then nothing, of course, is being done here. Now I'm going to make this part into a perfect square trinomial by taking half of the b term, which is 5, and squaring it. You notice that they wrote it as just 10 over 5 squared. They didn't write it as 25 squared. And then I'm going to do the same thing with the y terms. I'm going to take half of 8, so 8 divided by 2, which is 4, and square it. Now I have to remember that what's being added to this and what's being added over here in order to create the perfect square trinomial has to also be added to the right hand side of the equation. So I added a 10 over 2 squared, or 25, to this side, and I'm adding a 8 over 2, or 4, squared to this side. Now notice that this is being over here, this whole thing is being multiplied by 9, so that's the reason why over here they did 9 times this 25, and over here they're doing negative 4 times 16, because this represents 16, because when you put that in here, it would be multiplied by 9, so you have to do the same thing here. All right, so now I have this perfect square trinomial. It's very easy to write it in factored form. And so that's going to give me x plus 5 squared, 9 times the quantity x plus 5 squared. This is going to give me y minus 4 squared, and it's negative 4 still, times y minus 4 squared, equals, and then this all simplifies when you do 9 times 25 and negative 4 times 16. You subtract those and you add negative 197 to it. This all simplifies to negative 36. Now all I have to do is divide everything by negative 36, because we know that the equation is equal to 1. And so negative 36 divided by negative 36 gives us our 1. So now it's in standard form. And then over here, we're dividing this by 36 and this by 36. Now this can be simplified. 9 and negative 36 simplifies to negative x over 4. That's really 1. That's really negative 1/4 here. There's a 1 there, but we don't need to write it. And over here, 4 over 36. 4 goes into 4 once, and 4 goes into 36 9 times. So that also simplifies to 1/9. Okay, so we're almost done. We have one more thing that we need to do, and that is to rearrange things. And so we're going to rearrange it so that it looks like y minus 4 squared over 9 minus x squared minus the quantity x plus 5 squared over 4. So we'll write that. I'm going to go to a new page to do that. So that's going to give you the quantity y minus 4 squared over 9 minus x plus 5 squared over 4 equals 1. Okay, so now what can we tell just about this hyperbola just by looking at this equation? And you should have your notes in front of you, so you're seeing what I'm talking about here. First of all, I can tell that this is vertical because you've got your y minus 4 squared in front there, and that's always an indicator that it's vertical. And I know that A is equal to 3 and B is equal to 2. And I know that because it's always y minus k squared over A and x minus h squared over B. Now I can also tell the center then. My center on this is negative 5, 4. And I know that because when it gives me y minus k squared, then that means there's my k, because the center is hk, just like it was in ellipses and hyperbolas. And over here, my x minus h is telling me what I have for my h of my center hk. Okay? Now, the next thing is we need to find out what the vertices are, and on a hyperbola, the vertices are at the end of the transverse axis. On an ellipse, they're at the end of the major axis. So if we look at the transverse axis, then the first, you know what we should do? We should figure out how long the transverse axis is. The transverse axis is still the length of 2 times a, so 2 times 3 is 6. So we'll write that as TA equals 6. Okay? And then now let's talk about the vertices. And so the vertices are going to be your center plus A. And so I'm going to say it's going to end up being negative 5, comma, 4 plus 3, which is equal to negative 5, 7. That's one vertice. And then the other one is going to be negative 5, comma, 4 minus 3, which is going to be equal to negative 5, 1. Those are the two endpoints of our transverse axis. Notice that I added this 3, the a, to the y term. I did that because we already know that it's a vertical hyperbola, and so it's the y that's changing. It's going up and down. It's not going horizontally. Okay, now I'm going to change screens here, and let's talk about the foci. I just want to draw a quick picture. Sorry about my horrible sketch, but we'll do something like this. Now we know, whoops, we need a curve here. So there's your center, and then it's important to know that your foci, there we go, are inside the curve of your vertical hyperbola here. And so you've identified these endpoints. You identified this endpoint, and you identified this endpoint. And now we're trying to find these, the two foci. And to do that, we have to use the formula c squared is equal to a squared plus b squared. It's not the same formula as an ellipse. On an ellipse, it was, you had to do subtraction, remember. So here we're adding. Okay, so we already know that a is 3, and we already know what a and b squared are because we see that when we look at the formula, those two numbers. And so now if we do 9 plus 4, we get 13. So I'll just draw an arrow here. 9 plus 4, sorry, is 13, not 14. So c squared equals 13. We're going to square root this, and we're going to square root this, and c is equal to plus or minus the square root of 13. Okay, now we have to add that. So obviously that's going to be added to the y. And so if you look at your center again, which was negative 5, 4, I'm going to label that. You're going to have to add that to the 4, and you're going to have to subtract that from the 4. That's going to give you negative 5, negative 5, there we go, come on, negative, comma 4 plus the square root of 13 up here, and then over here, negative 5, comma 4 minus the square root. Okay, that doesn't look like a very good minus square root of 13. We have one last thing to do, and that is to find the equation of the asymptotes. And the asymptotes very badly sketched in here are these diagonal lines, and the curve of the hyperbola approaches and almost seems to touch, but it never does touch here. Never does touch here, although Mrs. Stephan can't draw. And the same thing happens here. So what we're trying to do is we're trying to find the equation of this line and this line. So because it's vertical, we know that the equation is y minus k. This was in the notes that I had you write down, equals plus or minus b, plus or minus a over b times the quantity x minus h. And so if we replace things, replacing things, I get y minus 4 equals plus or minus 3 over 2 times x minus negative 5. And by using the distributive property, I'm going to get y minus 4 equals 3 halves x plus 15 over 2. And y minus 4 equals 3 halves x minus 15 over 2. If I add 4 to both sides of these equations so they're in y equal form, that's going to give me y equals 3 halves x plus 23 over 2, and y equals 3 halves x minus 7 over 2. Now, you need to work on, and whatever you don't finish is your homework for this weekend, and now it's your turn on this hyperbola packet. Please make sure you erase and put the boards away for me and leave the room tidy. Leave 10 of the Chromebooks out for my next class. Put the other ones away. Make sure you sign out of all of them. Have a great day, guys. Bye-bye.